Okay, so we're looking at 2.4. The title says exponential function manipulation. So we're kind of rearranging these functions. We're kind of changing them to fit our needs for whatever we need, huh? It could be a translation. It could be. Yes. Okay, so at the very beginning of your paper, it says review important exponential rules. Review important exponential rules. So these rules come from the rules that you learned last year and the year before. These are our properties of exponents. Today we're going to use them backwards. It's one of the coolest things I've ever seen. So if I'm looking at the product property, what that says is when I multiply like bases, I add my exponents, right? The power property. If I raise a power to a power, I multiply my exponents. The negative exponent property. If I end up with b to the negative n, that's the same thing as 1 over b to the positive n. Are y'all remembering these? Okay. So now we're going to read them backwards. Start down here at 2x, 2 to the x times 2 to the third power. When I multiply like bases, I add my power. So that would become 2 to the x plus 3. But what if I see something on paper that says 2 to the x plus 3? What can I gather from the fact that they're adding exponents? That they had been multiplying the bases.
Would it not be 4 to the x plus
3? No, because you just keep your bases. You just add the powers. Right. So if I'm looking at properties of exponents and I see that they're adding, I can go back one step and say, hey, they must have been multiplying the bases. Mm-hmm. The base doesn't change because you're just combining the powers. If I had, I think, Truett, you're asking, why did the base not change? What if I had x times x times x? This is x cubed because I added 1 plus 1 plus 1. Multiply like bases, add my powers. It didn't change the base. Okay. All right, so these same exponent rules can be used when working with horizontal transformations of exponential functions. So example 1, it says determine the horizontal transformation of each one of the exponential functions. So we're looking at f of x equals 4 to the x plus 2. The plus 2 happens to be inside the exponential part with x. So what do insiders do? Lie. So if it says x plus 2, which way did this function go? It went left 2. Left 2. That's what you write on number or letter A. The horizontal transformation, it went left 2. Okay. Now, g of x on letter B says 2 to the 3x power. So now I've got 3 times x. It's still up with x, which means it's still an insider.
So it's to the power. No, it was divided by 3.
Yeah, it's divided by 3 because it's an insider. It's lying. So we've got a horizontal dilation. It's not a translation. Translation would be if they were adding or subtracting. This is a horizontal dilation by a factor. Say it again, Truett. Of 1/3. Horizontal dilation by a factor of 1/3. Remember, insiders lie. Insiders lie. So if it's 3x, the factor is actually 1/3. Because it's with x. He said, how do you know it's horizontal? Because where the 3 is with x. Okay? If that 3 was in front and you had 3 times 2 to the x, this would be vertical. But it's with x. So it's an insider located with x. Good. Because there's no parentheses. So how do you tell? It's location. Okay? Number C, or letter C. H of x equals 9 to the x over 2 power. Horizontal dilation. And what's the factor? By factor of 2. Insiders lie. So if it's to the x over 2 power, it's dilating by a factor of 2. Cool? Last one, letter D. K of x equals 5 to the x minus 1. Which way did it go, George? Y'all have not seen the cartoon. Apparently you're not 32. It's fine. It's fine.
Really?
Sometimes I make these references and sometimes they fall flat.
Curious George?
No. It was an old like Looney Tunes cartoon and the dog would run away and they would say, which way did he go, George? I don't know.
Are you talking about like Mindy and the dog?
It's fine. It went right 1. Right 1. How do I know it went right 1? Because it's minus 1 and it's with x, right? Okay. Carry on. Don't say bad words on YouTube. Now, let's re-examine the exponential function from example 1a and see if we can use our exponent properties to rearrange the function. So this is where we start manipulating, okay? They are saying if I had 4 to the x plus 2. So we're looking back at part A. Do y'all see that it was 4 to the x plus 2? If I had 4 to the x plus 2, that's the same thing as 4 to the x times 4 to the second power. The reason for that is if they're adding powers, they must have been doing what? Multiplying the bases. If they're adding the powers, they must have been multiplying the bases. So 4 to the x plus 2 power becomes 4 to the x times 4 squared. You seeing it? What's 4 squared? 16. So this could have been written 16 times 4 to the x power. Okay, so what if initially looked as a horizontal translation to the left 2 is actually a vertical dilation by a factor of 16. Those are the same thing. Huh? Oh. Okay, so those are the same thing. It says this means that f of x equals 4 to the x plus 2 is equivalent to writing f of x equals 16 times 4 to the x. Those functions would look the exact same on a graph.
Would you not be multiplying 16 times 4 in that last one?
So it's a vertical stretch of 16. Vertical stretch because that's a factor of 16. So the important idea here is that every horizontal translation is equivalent to a vertical dilation. Every time I'm moving it left and right, it's the same thing as stretching it vertically. Okay? All right, wait. No. Okay, so let's look at example 2. Let's dive a little deeper here. It says, each of the following exponential functions has a horizontal translation. For each, write an equivalent representation that has a vertical dilation instead. Okay? So we have 2 to the x plus 3. Another way of writing that, f of x equals, if they're adding the exponents, what could they have been doing? Multiplying the bases. So I could write it as 2 to the x times 2 cubed. So f of x could have said 8 times 2 to the x power. And now I'm not translating it. Instead, it's stretching vertically.
Where did the 8 come from?
2 cubed.
To the power.
Oh, light bulb. Light bulb.
And the 16 came from the 4 squared.
Right.
Oh, okay.
So that's where the vertical stretch is coming in. Those vertical stretch. So to stretch it vertically by a factor of 8 is saying the exact same thing as moving it horizontally 3 to the left. It's doing the same thing. Graph it. Somebody graph it. Nikki's not here. Hi, Nikki. Nikki's not here, so somebody's going to have to graph this.
So what do you do with the negative? Because it has a, what is that, -2? So would you just have a negative and then you'd have to do the negative exponent?
Give us a second. We'll get there in just a second. But you're right.
But it's still a 2 in the parentheses. That was our original base.
Right. Our base is 2. That has not changed. But when I have 2 cubed, now it's 8.
You're taking it out and putting it in.
Correct. Graph it. Somebody graph both. I want to graph 2 to the x plus 3 and 8 to the 2 times 2 to the x. What did you say, Grace? It's the same thing. These are equivalent representations. Okay. Everybody get the same thing? Okay. Ready to move on. G of x. G of x equals 3 to the x minus 2. So now they're subtracting powers. We could be dividing. Watch, I just like to rewrite it. First, I just rewrote it as 3 to the x times 3 to the negative 2. Which then helps me understand this is raised to the negative 2 power. I might want to do what? I might want to flip it. I might want to write it as 1 over 3 squared. Right? Make that power happy. So that's called 1/9 times 3 to the x. 1/9 times 3 to the x. That's what g of x equals. G of x equals 1/9 times 3 to the x. So what does that mean? It means to slide it to the left is the same thing as to shrink it vertically.
We need to expand this one back out.
Okay. Everybody okay? Yeah. Okay. Letter K or letter C. It says K of x equals 4 times 3 to the x plus 2. Whoa. Okay. So if I break that back down, I've got K of x equals 4 times 3 to the x times 3 squared. Are y'all seeing that? 4 to the x times, or 4 times 3 to the x times 3 squared. So now, if I put those all together, K of x is equal to, what's 4 times 3 squared?
36.
36. That's 4 times 9 would be 36 times 3 to the x power. So K of x, final answer here, K of x is equal to 36 times 3 to the x. You like this? Well, that's very good.
Give it a minute.
Are we good? Yes. Okay. Let's go to the back page. I really liked this. I didn't think this was too bad. Okay. So on the back page now, instead of dealing with the add my exponents or subtract my exponents power, now we're looking at power of a power. So when I raise a power to a power, I multiply. In reverse, that looks like if they were multiplying powers, then they must have had a power to a power. Okay? Does that make sense? Okay. A little bit. So we show here that every horizontal dilation is equivalent to changing the base of the exponential function. So they have on example 3, y equals 9 to the 2x. Y equals 9 to the 2x. That is 2 times x. If they're multiplying the power, okay, if they were multiplying the power, they must have had a power to a power, which would have been 9 squared to the x.
81.
Right? So we could have written it as 81 to the x power. So my answer here would be D. Yeah. It is. They all are. All right, example 4. Which of the following is the equivalent of the function y equals 9 times 4 to the x? Y equals 9 times 4 to the x. So that first number is not going to change. It's still going to be 9. So you could eliminate B and A. Okay? This is kind of interesting. They're calling that 4 to the x something different.
What do you mean?
So look at your answer choices. The 9 is 9.
It can't be 16.
It couldn't be 16 squared because that would have been 16 squared to the x. That would be a huge number.
It has to be square rooted. So
Right, it has to be square rooted. So they're saying that it's the same thing as 16 to the x over 2, which would be 16 to the 1/2 power to the x. Square root of 16 would have been 4 to the x. So here you would have started with your answer choice, and you would have ended up with the actual exponential problem.
yeah, if that was like a free response question, that wouldn't be what it. If
Probably-
you were trying to find a different one, and it just gave you the first equation, the 9 times 4x.
You could have called it 2 squared, or you could have called it 16 to the 1/2. There's 2 different ways to get a 4.
Is that it?
Uh-huh.
That's all we're doing?
That's it.
Homework.
That's it? We're done for the day?